Welcome to my first ever recorded mini lesson. Today we will be covering inequalities. That's 6-1 in your math textbook. Our EQ for today is how do you solve inequalities that involve one operation? And in our case today we're going to be covering addition and subtraction of inequalities. Make sure that you have a pencil and a piece of paper or a pen or however you like to take notes. And make sure that you are writing some of these things down because they are important and you will see them again. This video is separated into two parts. Part one is just kind of a revision of background knowledge that you will need in order to be successful in this section. And part two is the application of the knowledge that we will be covering in part one. So let's begin. Part one will be a review of terms, the number line, and number sense. So what exactly is an inequality? Well, make sure that you're writing this down. An inequality shows a relationship between two quantities that are not equal. So if two quantities are not equal, that means they will not have an equal sign. Yet there still is a relationship. And this may sound a little bit foreign to you, but you actually already have experience with inequalities. You may remember these two guys, less than and greater than. These two symbols are examples of inequalities. The way that we learned inequality with less than or greater than is that we use them to compare two numbers. So let's bring our number line up and let's generate some numbers. Now, if you are in my math class, you know that I mean these when I say number generators. So let's generate some numbers. Okay, we have 6 and we have 9. Oh, no, just kidding. This is two 6s. Let's find another number. 14. Perfect. Okay, so let's write down our values. We have 6 and we have 14. Okay, now the way that we determine which number is greater than or less than is that we look at our number line and we plot our points. Now, the way a number line works is that it starts at 0, and any number that is to the right of it is a positive number, and any number that's to the left of the 0 is a negative number. As your number moves to the right on the number line, on the number line, it gets bigger, or it gets more value. And as your number moves to the left, it gets smaller in value. So let's plot our points. We start at 0, and we go up to 6. Here's 6, so let's draw a dot here to represent our 6. Then we go up to 0, and we go up to 14. Okay, now remember we said that whichever number is more to the right is going to be your greater number. So in this case, our 14 is more to the right than the 6 is. Therefore, our 14 is going to be bigger. Now, when you first learned about less than or greater than, your teacher may have taught you to think about these symbols as if they were an alligator mouth. And they most likely told you to remember that the alligator is going to want to eat the bigger number or the bigger amount because, you know, alligators eat big stuff, I guess. So in our case, we're comparing 6 and 14. And we said 14 was bigger. So our alligator mouth is going to open towards the 14. So let's see which symbol that is. That is our less than symbol. So we're going to draw a lovely less than. What this means is that 6 is less than 14. And can you all agree that 6 is a smaller number than 14? We know that to be true according to our number line and also to our number sense. So we know that 6 is a smaller number than 14. When you see this sign here, what it means is that this value is less than or is smaller than this value here. So let's see an example for greater than. Number generators. Okay, we have, let's re-roll. Okay, 13 and 10. 13 and 10. Okay, now let's erase these plots, these plotted points that we've made, and let's start anew. Okay, so we start at 0 on our number line. We go up to our first value, which is 13. Here it is. And then back to 0 and up to our second value, which is 10. So now we look at this and we see which number is more to the right. Well, 13 is more to the right, which means that 13 is a bigger number than 10. Now, remember back to our alligator mouth. The alligator mouth is going to open towards the value that's bigger. So in this case, our 13 is bigger, so our alligator mouth or our inequality sign will open towards the 13. And we know that that sign means greater than. So this sentence right here says that 13 is a bigger number, is greater than 10, and we know that to be true. So we're already familiar with greater than, we're already familiar with less than, and in this 6-1 section of inequalities, we're going to introduce two new symbols. Now you may already be familiar with these symbols. They are very similar to the less than or greater than symbols, and they look like this. It is the less than or equal to symbol and the greater than or equal to symbol. Now you can see the similarities here between the greater than and greater than or equal to, and the less than and less than or equal to. And you're right to see similarities because they are similar. The only thing that's different is this line here. And what this line here represents is the or equal to part. So what these symbols say is that a number can be worth something or more. So how does that actually work in real life? And make sure that you have these written down, these symbols. Make sure that you know what these mean, and make sure that you know that these are all examples of inequalities. The way that a less than or equal to symbol works is like this. Say, for example, you want to buy a bag of chips, and that bag of chips costs around $2. You know it's at least $2. So if you wanted to buy this bag of chips, you're going to need at least $2. So $2 or more to buy it, right? Well, let's come up with some values that are more than 2. Well, okay, it can be 2. What's a number that's more than 2? 3. A number that's more than 2. 4, 5, all the way up to infinity, but we're going to stop here at 100. So in our situation, you're going to need at least $2 to buy this bag of chips. So let's go ahead and set up our inequality. We have a 2 here, and X will represent the amount of money that you need in order to buy these chips. Well, we know that you need at least 2 or more to buy these chips, right? So the way that this is going to work is that you're going to need 2 or more dollars to buy the chips. And remember, we said that our alligator mouth wants the or more part. So in this case, our 2 will be our more part, will be the greater value or equal to. So what this sentence here is saying is that 2 is greater than or equal to X. In other words, that this amount here needs to be at least 2, it can be 2, or it can be more than 2. And we already know that because we said that we can afford that $2 bag of chips if we have $3, $4, $5, $100, $1 million. Any amount that's 2 or more, right? So let's see a situation in which we would use less than or equal to. Okay, let's come up with a number, and that number is 14. Perfect. So say you live in a place that's moderately cold, maybe Russia or the Ukraine. Today in Georgia, our high temperature was 81 degrees Fahrenheit. What that means is that whenever you hear the meteorologist or your parent or whoever talks about the weather to you say that the high for today is a certain number, what they're meaning to say is that the highest temperature for that day is that number. So at any time that it's not the highest temperature, it's going to be a lower temperature. So in our example, our high for the day is going to be 14 degrees Celsius. So when it's not this temperature, it's going to be a lower temperature. So what's a lower temperature than 14? Well, if you're not sure, you can look on your number line. Here's our 14. So all of these numbers are numbers that are less than 14. So let's pick some random ones. Let's say 9 degrees Celsius is less than 14, 3 degrees Celsius, -6 degrees Celsius, -8 degrees Celsius. These are all values that are smaller than this 14 degrees Celsius, which in our situation, this represents the high temperature for today. And I'm going to write a little HT to represent that. So how would we write that as an inequality? Well, we said that the highest it could possibly be will be 14, right? And X is the temperature for the day. If it's not 14, that means it's going to be less than 14. So that means that X is going to be less or equal to this number. So remember, our alligator mouth is going to want the bigger one. So in this case, this 14 is bigger. So we're going to use this symbol, the less than or equal to symbol. And what this means, and let's just go ahead and write a little 14 degrees Celsius. What this means is that X is either equal to 14 or X is less than 14. And we know that to be true because when it's the high temperature, that means if it's not this degrees, if it's not this temperature, that means it's a lower temperature. So this says X is less than or equal to 14 degrees Celsius. So far in this video, we learned what an inequality was. We reviewed less than, greater than, and we learned about less than or equal to and greater than or equal to. So I'm going to move this definition out of the way, and I'm going to move these guys over here. Now, the addition and subtraction property of inequality states that you can add or subtract the same number on both sides of an inequality, and the inequality will still be true. Well, what does that even mean? I will show you. First, let's generate some numbers. Remember, you can add or subtract the same number on both sides, and the statements here will still be true. So let's come up with a number. Okay, we have 2. So let's say we're going to add 2 to this side, and we're going to add 2 to this side. Now, if you're in my math class, most likely you've seen me recommend for you to split your equation. Well, these aren't equations, these are inequalities because there's no equal sign. So in this case, to split your inequalities in half. So the way that you do that is starting where, instead of our equal sign is, our inequality sign is, you just draw a straight vertical line down, and that's going to separate your inequality into 2 parts. The same way that we've been solving these one-step equations, you're going to separate them into 2 parts. So we're going to add here, 3 plus 2 gives us 5, and I hope you all know that, and 11 plus 2 gives us 13, right? And then we just bring down our sign. So let's see if this is still true. Is 5 still less than 13? Let's check our number line. Is 5, here's our 5, and here's our 13. Is our 5 less than our 13? Yes, because our 13 is more to the right than our 5 is. So we know this is true. In this case, let's subtract 2. Minus 2, minus 2. Separate your sides. 6 minus 2 gives you 4, and 2 minus 2 gives you 0. And then we bring down our sign. Now let's check it. Is 4 greater than 0? Is 4 a bigger number than 0? We know that yes, because hopefully you know that 4 is a bigger number than 0. And also according to our number line, our 4 is more to the right, therefore our 4 is a greater value. So yes, this is still true. Let's do this one over here. So let's add 2 plus 2 plus 2. Separate your inequality. 1 plus 2 gives you 3, and 17 plus 2 gives you 19. Bring down your sign. Is 3 less than or equal to 19? Well, yes, we know that 19 would be over here. We definitely know that 3 is a smaller number than 19. So yes, this inequality is still true. And our last one, we have a 5. So let's subtract 5. Minus 5, boop, minus 5. 19 minus 5 gives you 14, and 9 minus 5 gives you 4. Bring down your sign, and then you ask yourself, is 14 greater than or equal to 4? Well, here's 14 and here's 4. Is 14 greater than 4 or equal to 4? It's definitely greater than 4. So we know that this inequality is still true. So in the section we're going to cover today, you will not only learn how to solve inequalities using addition and subtraction, but you'll also learn how to graph them. So before we move on, we are going to learn what symbols go with the graphing. So we have less than and greater than, and we have less than or equal to and greater than or equal to. Now there's actually a way you can plot this on the number line, and you're going to use 2 different symbols. Now these may also be symbols that you've seen before. They are the ray with the closed circle and the ray with the open circle. Make sure that you have this written down somewhere, that the closed ray circle goes with these 2 symbols, and the open circle ray goes with these 2 symbols. This is important. Make sure that you know this. So how do we actually use these? Well, let's go back to our examples. Okay, we have 20 and 19. Let's put 2 other numbers. 14 and 5. Okay. So what this number sentence here is saying is that x, our variable, is greater than 5. So how would you plot that on a number line? Well, I will show you that now. Okay, so let's get our red marker this time. We're saying that x is a number that's greater than 5. So it's not 5, it does not include 5, it's not equal to 5, it's a number greater than 5. So the way that we denote that is, go to your number line, go to 0, go up to 5. And this is when you're going to draw an open ray, an open circle ray. So starting at 5, draw your open circle. And we said that x is greater than 5. So if it's greater than 5, that means that it's any number that's bigger than 5. So not including 5, we're going to go to the right. And we know that on our number line, if you go to the right, that means you're increasing the value of your numbers. So here what this ray says, what this line says, is that our x, our variable, our variable is a number that's not 5, but it's a number bigger than 5. So it's any number bigger than 5, any number to the right of 5. So how would we show that with less than? The same way. So let's erase our ray right here. And let's come up with another number. Okay, we have 9. So in this case, we're going to say that x, 9 here, and we're saying that we're going to use the less than. So in this case, in this number sentence, it says that x is a value that is less than 9. So back to our number line, start at 0, go up to 9. And remember, we're not including 9. We're saying any number less than 9. So we draw our open circle ray starting at 9. And we said it's any number less than 9. So less is going to go to the left. So you're going to draw a line and you're going to put an arrow at the end. And that arrow represents that it's any number going this way. So that's what this represents here, that it's not 9, but it's any number less than 9. Okay, so how do we denote the less than or equal to or greater than equal to? Well, let's use our examples that we used earlier. Our temperature example where x was less than or equal to 14, and our chips example where we said that 2 was greater than or equal to x. Okay, so let's start with this one. In this one we're saying, or we said that the temperature could be equal to 14 or it could be less than 14. So we go on our number line. Start at 0, go up to 14, and this time we are including 14 because the high was 14, so the temperature can be 14. So the way that you show that is with a closed circle because we are including 14. And we said that x is going to be less than 14, so that's going to be any number to the left. Left, less. So this ray right here with our closed circle represents that x can be 14 or it can be any number less than 14. Okay, so that was the end of part 1. In part 2, we're going to apply what we just went over to inequality problems. This is going to be how you will see it in your math classroom. So part 2, begin. The thing about inequalities is that you solve them pretty much the same way that you solve the one-step equations that you have previously learned about. And in case you don't remember how to do that, I created this nifty little guide called your Inverse Operations Guide. And what this says is that whatever the problem says, whatever our inequality says, you're going to solve it the same way by using an inverse operation. So here's what the problem says, and here's what we're going to do. So let us come up with some examples. Let's say you have x minus 12 is greater than 32. Okay, so we're going to solve it the same way that we solved our one-step equation. So here is our inequality sign, which is where the equal sign would be. So you're going to draw a vertical line to separate the sides of your inequality. And this here says subtract 12. So if our problem says subtract, what we're going to do is the opposite. So we're going to add. So what's the opposite of subtracting 12? It's adding 12. And what you do to one side, you do to the other side, just like in our one-step equations. So now this negative 12 and positive 12, these are going to cancel out. That's a 0 pair. That means that negative 12 plus 12 is 0. So all you have left on this side is your x. You bring down your sign, and here you have 32 plus 12, which gives you 44. So in this case, x will have to be a number that's greater than 44. So how do we check it? Well, you pick a number that's greater than 44. In this case, let's just use 45. And we're going to plug that into our x. So our original inequality was x minus 12 is greater than 32. So we're going to plug in 45 for x. 45 minus 12 greater than 32. Let's see if this is true. 45 minus 12 gives you 33. Bring down your sign, 32. Is 33 a bigger number than 32? The answer is yes, that is true. Okay, so let's do another example. Let's move our inverse guide to this side. And let's say we have C plus 9 is greater than or equal to 20. So again, under our inequality sign, we're going to draw a vertical line to separate the sides. And here we have a plus 9. So if the problem says to add, we're going to do the opposite. So the opposite of adding 9 would be subtracting 9. What you do to one side, you do to the other side. So again, our zero pair cancels out, and you have C is greater than or equal to 20 minus 9 is 11. So again, if you want to check it, what you're going to have to do is plug in either 11 or a number greater than 11. So let's do a check for both of those. Okay, we have plus 9, 20. Now let's see if this is true. 11 plus 9 gives you 20. Is 20 greater than or equal to 20? Well, we know that 20 does equal 20, therefore this is true. Now let's try with the number bigger than 11. Let's try 15. 15 is bigger than 11. 15 plus 9 greater than or equal to 20. Let's see if this is true. 15 plus 9 gives you 24, greater than or equal to 20. Is 24 a number that is bigger than or equal to 20? Well, yes, we know that 24 is in fact a bigger number than 20, so this again is true. Okay, so let's try an example where we will graph our inequality. So let's say that y minus 7 is greater than or equal to, let's say, 5. So here's our inequality sign. We're going to draw a vertical line to separate the sides of our inequality. And let's bring out our operations guide. This here says subtract. So if the problem says subtract, we're going to do the opposite. So we will add. So the opposite of subtracting 7 is adding 7. And what you do to one side, you do to the other side. So these zero pairs cancel out, and it leaves you with y is greater than or equal to 5 plus 7, which gives us 12. So let's bring out our number line so we can graph it. We know that the greater than or equal to signs and the less than or equal to signs, they match up with the ray that has a closed circle. So starting at 0, we go up to 12. Here's our 12, and we're going to draw a closed circle on that 12 because we're including that 12 in our values. Now, this says that y is greater than 12. So if y is more than 12, that means that our arrow will go to the right because this way our values are increasing. The numbers get bigger as they go to the right. So this is how you would graph this inequality. You would say y is greater than or equal to 12, and you would say our values include 12 and any number bigger than 12. That's how you would graph this. Okay, so let's try another example. Let's say you have m minus 14 is less than negative 3. Okay, so you draw your vertical line at your inequality symbol, and again, our problem says subtract, so we're going to do the opposite of adding. So we're going to add 14 here, and we're going to add 14 here because we want to isolate our variable. So these cancel out, and it leaves you with m is less than and negative 3 plus 14. Now, my students have a guide in their agendas with the rules to operations. Okay, so this is a negative and this is a positive. So we have two numbers with different signs. So in this case, we will subtract and keep the sign of the bigger number. So 14 minus 3 gives you 11, and the bigger number is this 14, and the 14 is positive. So our 11 will be positive. So let's bring our number line up. I'm going to delete this. We're going to erase this that we already graphed. And starting at 0, go up to 11. And remember, the less than or equal to signs, they go with the ray that has the open circle. So at 11, we're going to draw an open circle. And we said that m is less than 11. So if it's less than, less, left. So we're going to go left on our number line. And we're going to draw our arrow to represent that m is not 11, but it's any number less than 11. So in this video, what we have learned so far is the definition of an inequality, which is it shows a relationship between two quantities that are not equal, and we learned the symbols for inequality, and that was less than, greater than, less than or equal to, and greater than or equal to. We also learned that the open circle ray is how you graph a solution or how you graph an inequality on a number line, and that a closed circle ray is how you graph an inequality on a number line. We also learned how to solve one-step inequalities, addition and subtraction, and here is our reminder of our inverse operation guide. Just like our one-step equations, we solve one-step inequalities the same way. You do the inverse operation. We were also reminded about our number line and the way that it works. So thank you so much for watching this video. If you are in my class, you do have homework, and I do expect to see this on Wednesday, but it's very easy. You have page 132 in your math textbook, 1 through 6. That's 6 problems. You can do this. I will check this on Wednesday when we have our class. But anyways, that was inequalities 6-1. I hope that you guys now know how to solve for inequalities that involve one operation using subtraction or addition. Thank you so much for watching, and I will see you in class.